Okay, hi everyone. Thank you so much for joining us. Today, the Microscopy Society of America Student Council is putting on the Communicating Science webinar. So my name is Jenna Wardini. I'm a PhD student at UC Irvine, and I'm also the social chair for the 2020 Pre-Meeting Congress at Microscopy and Microanalysis. So quickly, I just want to plug the Pre-Meeting Congress. This is like it's hosted on Saturday before the Microscopy and Microanalysis Conference, and it's a chance for early career professionals and students to kind of meet and talk about their work, and there'll be presentations and poster sessions and things like that. So it's a great opportunity. There's lots of cool social events around that also. So I am the social chair, so if you guys don't have fun, you can blame me for that later on. Anyways, more importantly, I am moderating today's webinar, and I'm actually co-moderating with Aubrey Penn. So Aubrey can introduce herself.
Hi, I'm Aubrey. I am the MSA Student Council Secretary and excited to be here.
Okay, so thanks, Aubrey. So by this point in our careers, we're all aware that communicating our work to our peers is extremely important. So even if you're doing fantastic work, it doesn't have a big impact if no one hears about it or if you can't communicate it effectively. So the panelists that we have with us today have experience both in communicating their work as professors and researchers, and in reviewing the work of others through some secondary professional roles that they have that they'll discuss in their introductions. So the goal is to learn from their tenure as science communicators and get an inside look on this process of reviewing other people's work, and what are things that people do that make them successful in communicating their work, and what are the common pitfalls. So before we get started, just a note to the attendees. If you have questions for the panelists, you can put it in the chat window. So if you look at the bottom right of your screen, there's a chat window. You can type your questions there, and Aubrey will be monitoring the chat window, and she'll, let me know that you guys want to participate. So anyways, also, if we want to know that you guys showed up, so please put your email address in the chat window also, and we'll make sure that you're entered for the Amazon gift card. Shows that you were here and participating. So without further ado, I will let the panelists introduce themselves. We can start with you, Dr. Picard.
Okay. Hi, thanks, Jenna. So my name is Yoosuf Picard. Did my undergrad at Louisiana Tech in Mechanical Engineering, my PhD in Material Science and Engineering at University of Michigan, 2-year postdoc at the U.S. Naval Research Lab, 10 years as research faculty at Carnegie Mellon University, and now currently I'm a research scientist at the National Energy Technology Lab in Pittsburgh, Pennsylvania. Research background, scanning electron microscopy, transmission electron microscopy, materials, so it runs the gamut of metals, ceramics, semiconductors, microstructure defects, atomic scale, structure, properties, correlation, magnetic, electrical, optical, mechanical, you name it. In terms of service activities, I've done some organizing of conferences on electron backscatter diffraction through the Microanalysis Society. I was a director in that society for 3 years. In Microscopy Society of America, I've previously been a focused interest group leader on electron crystallography and diffraction-based methods. I've also been a program co-chair, as well as the organizing or technical program chair for the Microscopy and Microanalysis meeting in 2018. So I can speak to some of those things about conferences, organization, service activities within MSA and MAS. And I can also talk about my recent activities as an editor for the Microscopy and Microanalysis journal through Cambridge Press. All right.
Awesome, thank you.
Sure.
Dr. Xin, would you mind introducing yourself? Dr. Xin? Are you, we can't hear you if you're talking. Did we lose him?
It looks like he may have lost connection.
Oh no. Okay, well, we can move on for now, and if he joins us, we'll give him a chance to introduce himself. Is that him? Let's see. Okay. Hi, Dr. Xin? Okay. We'll move on for now, and then we'll come back to it when we hear from him. Okay, so Dr. Picard, you said that you were a program chair, a program co-chair for Microscopy and Microanalysis Conference. So can you tell us what the process looks like for choosing submissions to M&M for presentation? So once you submit your abstract, who reads them and who decides what submissions deserve a time slot for presentation?
Rule number one of submission to the Microscopy and Microanalysis meeting: they're not abstracts. They're abstracts, but really they're 2-page papers. And so that's one definitive feature that is different from our conference versus other meetings. Because it's microscopy and microanalysis, when you submit for an oral or poster presentation, yes, you're giving an abstract, but it's an extended abstract, and there's an expectation that there's figures there. So you actually have to show data, rather than in other meetings like MRS or MS&T, TMS, ACERS, what have you, where you might just have to provide a paragraph. So you actually have to show some preliminary data, even with citations, and that those papers of themselves are actually citable. They actually have their own DOI number and they can be cited. Having said that, there's a lot of emphasis on the figures of the presentation, the data, and that goes a long way towards, especially for students, the number of the many awards that are available for early career scholars. So both, especially for students through M&M, both the MSA and the MAS societies, they sponsor different awards. And being in the process of the selection for that, because they come from a diverse array of different research areas, while we try to have a broad breadth of expertise that look at the papers, a lot of it comes from a sense of, wow, this person put in a lot of work already, even before you get to the meeting, because we're not judging based on the quality of your presentation or your poster at the meeting. These awards are actually presented at the conference. So the selection is actually done beforehand. It's usually done at the program planning meeting in March, and that's based on what you have submitted, but usually the deadline is mid-February for the paper submissions. So having a lot of data, giving a very solid presentation of that 2-page paper, that's everything for being able to win those awards. And as such, that's the major thing that you, if you want to focus on, yes, impact matters and how you write it up and what you cite, but putting as much data into a coherent story, which can be a real challenge because you only have 2 pages. You don't have more than that. And so you have to really show that you almost have the whole story done. You may not, but you can have to convey that quite a bit has already been done, even though you're going to be able to do more between February and when the actual meeting occurs in August in terms of what you present. So just keep that in mind, that if you think about submitting to microscopy microanalysis, you want to have a lot of the work already done and a lot of data already in hand. Whereas for other conferences, you may not necessarily have that. You may have enough to say, hey, I have a powerful abstract, but you don't have to show any data at that point. And for M&M, you definitely do. Okay,
that's interesting. So this year, I think the submission format has been changed a little bit. Is there, can you talk about what the differences are and why, do you know why that decision was made?
I'm out of the loop. So once I did my stint in 2018, I wasn't even there for 2019. So whatever the discussions were, I wasn't in on that. And yeah, I see that they've changed from, was it to 1.5 pages?
Yeah. It said originally it was
I'm not sure.
Yeah, okay. That's a question for Dr. Xin, if we can get him back here.
right?
Well, yes, I'm actually back. So.
Oh, you're back. Okay, great.
Yeah, great. To answer the question, so first of all, now it's not going to be a Word document that's going to be submitted. So you will have online web form that you basically input the title, the abstract, and all the contributing authors. And now figures are not requirements anymore. So you can opt in not submitting any figures. However, if you want competing for any of the awards, so one figure is required. So one of the reasons they have been changing this, and first is primarily to lower the burden on the society. So every year, so we have the program production meeting where some of the organizers, the meeting chair, all get together, and we need to check the format of every single paper that has been submitted, which is really time-consuming and costly for the society. So one way that's saving the resources, both human and monetary, that's for the sustainability of the society. And secondary, so the meeting, we want to attract more and more biological scientists to get involved with M&M. And the culture that they have is that they don't want to put any results, unpublished results, into an abstract such that it will affect the publication of their future papers results. So there's a little bit of culture difference. So I would say now is a really good compromise that you can choose whether you just only want to write some text or you want to be considered for awards. You can submit more data for review. All right.
Okay, that makes sense. Thank you for clarifying that. So another question about submitting for microscopy and microanalysis. What does the program committee's grading rubric look like? So I'm assuming you submit to a certain symposia that you think matches your work, and I'm assuming relevance to that symposia is important. The topic, like how fashionable it is at the time, what the research impact is, how well written it is. What are the most important things out of that list, do you think?
Is that for Yoosuf or for me?
Oh, it's for anybody. Everyone can answer.
So in my opinion, of course, Yoosuf had just talked about it. So the quality of the research, the quality of the data is the most important thing. And of course, because the format changed, if you don't have any figures submitted, and of course it will be slightly more difficult for the symposium organizer to actually judge the quality just by reading the text. So it would be really helpful to submit some figures, and that is so the originality, the quality of the research both matter.
Okay.
And something I'd like to add to that, because I know at 2018, Dr. Xin, he hasn't been able to go through the PPM just yet, because that's going to be in a couple of months. But what I will speak to in the past is, and one thing to keep in mind for any people that are looking to submit, if you don't see the perfect symposium in this scientific program that best matches what your research area is in, don't let that discourage you. Pick the best one, the most closest, and go ahead and submit. And even if it seems like, oh, it might be an outlier, what happens is, sometimes we'll see, wow, there's a lot of these flavor of papers. They don't quite match the symposium, but they are kind of accumulated here. And some things can happen. It doesn't happen every year, but we can actually create a new symposium just because we have so many papers in this one area, or we may actually pick some from some other areas and build up a symposium around that. So some people, you know, I talk to them, they say like, you know, I just didn't see the symposium that I expected to see from previous years. Some symposium are designed to be there every other year. But having said that, even if you don't see the Magic Symposium, go ahead and submit. And the other thing is, if you know, not for biology, but for the physical sciences especially, if you, now that you can't, people have submitted papers without data in the past. And if you do that, you're almost guaranteeing yourself only a poster presentation. It's really, you know, there's only a select number of slots for platform oral presentations. And so normally in the selection criteria, there's going to be deference for those who actually have shown some preliminary results in the form of figures. And if you kind of say, well, I'm not going to, you're putting yourself in the position of very likely being maybe accepted, but only for a poster presentation in that symposium that you submitted to. Right.
Okay, great. Thank you. So you have this meeting where you all get together and review all of the submissions. That there has to be so many submissions. How many people, is everyone reading all of them? How does that part work? It just seems sort of unmanageable. Like, does everyone read? Like, how many people have to go through? Is it just like people for specific symposia will review the submissions, or how does that work?
Huolin, were you there for the PPM last year?
Yes, yes.
Yeah.
First of all, the symposium organizer typically between 2 to 4, and they will all first read all of the submissions in their own symposium. And later on, what will happen next at a program production meeting that typically happens in March is that there will be another set of people that will go through these paper again. So both for checking the format, and also they will have a cursor reading of these submissions. And sometimes we will reject actually a few of them just because either the science in it looks fishy, or it's actually not a scientific abstract, it's something like an advertisement, something like that. So you can say there will be between 4 to 6 people that have read this submission during the whole review process.
Okay, interesting. So another thing is, what makes a submission really stand out to you? I mean, you read so many of them. What is something that can people can do to set themselves apart?
Yoosuf, you can maybe comment on that first.
Yeah, sure. I think one thing that tends to stick out is the number of methods, right? If you have complementary methods, correlative analyses, you do microscopy and spectral analysis, the more tools that you're putting together for that specific problem, for that specific research project, the more impressive that's going to be. And this M&M, the Microscopy and Microanalysis, it's designed to be around techniques. And while it may specify this technique or another, if you read through the descriptions over and over again, it's highlighted how we're using this one method in conjunction with other methods. And so, you know, a person that's able to show that they're looking at it from many different angles, that's powerful. Having said all that, if you're applying computational methods, machine learning, some algorithms, that is extremely favorable in general. But if you're able to take a lot of data and do a lot of analysis, even if it's with one method, but you're pulling out a lot of information that's fruitful from that one method, that can also be very impactful too. And again, when I say this, it's the figures and the data that really sets you apart. And that's what tends to stand out.
So I can add a couple points on that is, the novelty is very important, and And also what's important is, so M&M is heavily focused on techniques, on instrumentation, but also science cases are important as well. So you basically can have a very technique-wise or technique-savvy submission that's focused on development on certain aspects of microscopy and microanalysis, and if you go in that direction, that would be certainly very good. That fits very well in this conference. That typically what the symposium organizers favors depending on which symposiums they are, but there are other physical sciences symposia that are heavily focused on application of these microscopy technique and microanalysis technique on certain aspects of science cases. Then if you have a really good one that have good application of these tools, that can also be built favorably. So of course this conference welcome all types of work, both in terms of technique development and also applications.
Okay, great, thank you. So the next few questions were sort of directed towards Dr. Picard for his work as the editor of Microscopy and Microanalysis. Dr. Xin, if you have experience, I'm sure you do, reviewing papers and things like that for journals, feel free to jump in.
Sure.
So first of all, Dr. Picard, can you describe your role as editor of Microscopy and Microanalysis?
Right. So if you look at for any journal, you'll see an editor-in-chief or a number of editors-in-chiefs. You may see an editorial board, and then you may see different editors. As an editor, I work under the editor-in-chief, who's John Mansfield, and I, as well as about a dozen others in various categories within our journal. So what my job is when any submission goes to the journal Microscopy and Microanalysis, the editor-in-chief looks at it first and then decides based on the general scope and theme of the research, which of the editors it should be assigned to. If a journal article comes to me, or some manuscript submission comes to me, usually there is a step in the process where someone reviews it for the basic format, make sure that things are legible, that the figures are properly actually viewable, legible, fonts, that sort of thing. If anything needs to be fixed, that might be sent back to the submitters before it reaches the editor. But once it does, I take a look at it, make a scientific determination regarding the quality of the work. Does it fit the journal? Does the science seem sound? Does it seem reasonable for submission in this journal? I may decide, no, it actually is better suited for a different journal. I can make a recommendation right off the bat to the submitters that, well, based on what you're describing here, these might be better suited journals. And I'll go, I'll do my part to try and actually suggest specific journals that they should consider submitting to versus ours, and give a statement as to why. If I ever do make that determination that maybe an article, a manuscript submission should go to a different journal, I usually use the wording straight from the website of our journal in terms of what we emphasize. And what Microscopy and Microanalysis emphasizes is both development of techniques, so new applications, or as well as application or utilization of those techniques to specific problems or research areas of interest across biological, physiological, and physical sciences. So, so a lot of times I might get an article that they're really focused on a particular problem, and they use microscopy, they do some microanalysis, but it's very basic, it's very rudimentary, straightforward. There's nothing new there. It's not necessarily what they're describing, or maybe what they're analyzing might be new, but if it's based on what they're describing, they're citing a lot of literature that is in the specific area. and that the impact of their research is going to be primarily of interest to those who are already studying in that particular field, that journal needs to be in that field. It needs to go maybe into tribology or to ceramic coatings or thin films, vacuum science, something else. Microscopy and microanalysis, it's a very broad audience. So that those journal articles might be of interest to people that are doing biological imaging, as well as optical microscopy for metallurgy or metallography. It's very broad, right? So if there's a really interesting use of an optical microscope in a new way, or using different filters in a different way, you know, that might actually have application across many different areas, not just the one that the specific topic that they're studying, then that is something that's more appropriate for our journal, right? So just hope that clarifies and makes some distinctions, because we do get a lot of submissions. I think because of the nature of the journal, it's like, well, we did some microscopy, we did some microanalysis. So if there's any place that we're not really sure where we could submit it, let's just put it in this journal because it fits. And that's not necessarily the case. Once I make a determination that what is submitted is good science, the writing is reasonably good, and that it fits within the scope of this journal, then I go through the process of trying to find reviewers. So I'll look into the field. While I'm looking into it, I'll look at similar literature that's already been published in that particular area. So both in terms of techniques, like, oh, you're doing X-ray photoelectron spectroscopy. Okay, who's doing XPS for these types of materials as well? That helps guide me to find good reviewers for this journal, but for that particular manuscript, but also to determine if this is actually timely. Is this really pushing it, or is it actually, you know, more a standard approach that other people have been doing for a number of years already? And in the process of doing that, even in the process of both looking for reviewers and looking at, well, what other submissions out there, both in our journal as well as other similar journals in microscopy or microanalysis on this particular topic, I have on occasion found people that have already published their results. And that happens. People will take their results, they'll crop the figures, they'll do little things to change it and slightly change the story, and then go to this journal, go to this one. And so from one okay study, they will be able to pull out 3 or 4 journal articles, but it's all the same work. It happens. And so, you know, so there's 2 reasons why, even though I'm not in that particular field, I cover a broad area. A lot of the journal articles that I look like are going to relate to scanning electron microscopy, applied to all different realms of physical sciences, as well as a little bit on the spectral side. So whether that be WDS or EDS, energy dispersive spectroscopy, or even electron backscatter diffraction, those sorts of things, because that's where I've had a research background and interest in. So in the process of looking out there, what's been done in literature comparable to that, we try to do due diligence in looking for and occasionally catching people trying to repackage their results to multiple journals, including ours. It happens. But once, you know, I get through that process, I find reviewers. We have a database in a program where we can send the manuscript for review to the reviewers. Once I get the reviews back for that manuscript, I look at the reviews and I make a determination if it should be accepted as is, which never happens. If it could be accepted with some minor revisions, accepted with some major revisions, or even outright reject. And, you know, I've had one reviewer say, this is a paper that's fantastic, no changes necessary. And then the other reviewer, second reviewer, says, absolutely reject this, this is terrible. And so I have to go and look and figure out what's going on. So 9 times out of 10, if someone says, wow, there's nothing wrong with this journal, they didn't really look at it closely, or they just didn't really put in the time. It happens. People are busy and they mean well. But I have to be the one to kind of check and say, well, did they actually look at it? So what that will often entail me doing is I'll be the pseudo third reviewer, which means while I did a cursory review of that submission initially, just to get an idea of that, they had a good abstract, they have a good study, and that their figures are generally fitting with the abstract, I'll really start to look, just as any reviewer would, and say, okay, hold on, what are they actually extracting from this figure? Where in the text are they referencing it? Does it really actually support their conclusions? You know, so I'll go in, and as I do that, I can start to see whether the rejection person or the accepting person was probably more fair. Usually, if there's a rejection, if someone recommends that, they will say why, right? Because you have to validate that. And usually that sticks out. It's like, oh yeah, I see what they're saying. There's some major issues here. Okay, well, then I will echo some of that feedback, even add some additional things that I saw in addition to the reviewer. And the last thing I want is for someone to be rejected from our journal with no real explanation as to why. That's the worst. Whether they had a good or on the fence or, you know, just wasn't quite there, I want them to have the feedback so that the next time they submit, they got a really solid shot of being accepted. So we give constructive feedback, and sometimes the reviewers give enough, sometimes I have to add a little bit more to kind of help coach them and say, this is what you need to do if you even want to try again, and good luck. If things look good, if there's only some revisions, you know, that 2 or 3 or 4 reviewers are giving on the manuscript, then I send it back, that feedback back to the submitters. Hopefully within a reasonable time frame, they able to give a new submission. And then I look at it again. I look at the comments from the previous reviews, and I see, and usually there's a cover letter that goes with it that it outlines, and cover letters are very important. I might as well stop and say that right now, because sometimes it's optional with any given journal. But when you submit a manuscript, you usually have the option to include a cover letter. That's actually really important, and I will look at those cover letters, and here's why. You have to use technical language when you write in your abstract, in your introduction, and your summary conclusions. But especially for really good papers, you kind of want to say, this is awesome. Do you know how awesome this is? No one's done this. Like we've really looked in the literature. No one's really done this. And there's so many good implications. And there's a style, appropriate style of writing that you have to do in the body of the submitted manuscript. But it's hard to convey the punch that you'd really want to convey. And that's what you can do in a cover letter. So you can talk more person to person in the cover letter, less in the abstract technical sense. And you can really highlight, look, we really think this is a good paper. This is really good for this journal. Here's why. This is really timely work that we think, blah, blah, blah. So that's where you can actually get a really good sales pitch for your article, is in the cover letter. When you first submit, and editors look at it, at least I do. And it actually goes a long way towards making me feel good about passing this paper along to reviewers. Because when I do ask people to review, I'm asking for a decent chunk of their time. And I don't want to waste their time if, you know, I made a mistake, I thought I was thorough, but really this is not new. This is not timely. So anything that you can do to help me feel like I'm making that the sales pitch is there, that I'm going to actually give a good quality product to our reviewers to look at, that's going to make me feel better to do. At the same time, once you have your feedback from the reviewers and you're now making the revisions, the cover letter is really important to make sure that this is all done right. You've got to tell me what you changed, where everything needs to be detailed, because I need to see it. I need to make sure that the reviewers are going to be able to follow it as well. So I have to look at it first. And if I say, no, you actually did not address many of these reviewers' concerns, which I think were legitimate, I'll send it back to the authors first before, again, I'm asking the reviewers to look at a second draft. I really have to make sure it's worth their time to do that. Give a good cover letter, and then that's going to create a lot less work for everybody. That's going to make your submission leading to actual acceptance go that much faster. Cover letters are very important, both at the beginning as well as during the revision stage. Once everything is revised and everything looks good, we send it off to be published. And hopefully things go well. It's 1 to 2 cycles. And that's the process for the most part. And I hope that makes sense, right?
Yeah, that was a great description. You actually covered my next 4 questions that were on my list.
I just want to echo Yoosuf's comment on the importance of the cover letter. So, so one of the advice that I could give is that when you write a cover letter, you don't just want to copy and paste your abstract. I know a lot of people do that. Some of the sentences in your manuscript. What you really want to do is actually think about, is there another angle that you think your work is really important, and you want to describe that to the editor? Take it as a challenge, right? So I do that all the time, even with my, even if it's on this paper is not, I'm not a main contributor, and I write these things into the cover letter, and many times, my collaborator actually took those sentences and put back into the manuscript, and it just can tell, if you really pay some attention and really do some work on brainstorming why your work is important, and really helps you actually strengthen, your work, to convey your message to both the editor and also the reviewers.
Okay, that's great. Thank you. I just want to take a second because Dr. Xin, we missed your introduction because we lost you there for a second. Would you mind giving us a little information about your history? Like, have you acted as a reviewer? Have you anything that I didn't list about, like what you have done besides being the professor and the program chair of microscopy and microanalysis? Anything you can add?
Sure. So just a little bit about, I got my PhD from Cornell University, and after that I did a 2-year postdoc at Lawrence Berkeley Lab, and then I moved to Brookhaven. I worked there for 5 years as a staff scientist, and then I moved to UC Irvine 1.5 years ago. So I've only been at UC Irvine as a faculty member for 1 year and 2 quarters. So that's a very brief history about myself. So other than the fact of being a program chair for M&M, so I've been relatively actively in organizing symposia for our conferences, and also basically get involved in the some of the focus interest groups, for example, liquid and electron microscopy for liquid and gases, and organizing the pre-meeting congresses for our focus interest group. So that's some of the professional activities I've been involved in.
Okay, great. So I'm assuming that you have been asked to be a reviewer at some point.
Mm-hmm.
What were things that stood out to you as far as like the communication aspect? Assuming the work is the same quality, how does the communication make you feel about publishing a paper?
Right. Okay. So if now, of course, I view the novelty and also the quality of the research the most important thing. However, given the same data, different people can tell different story. So that's where the communication becomes extremely important, right? Writing a really good abstract and the first paragraph for the introduction is really important. That's where actually where the editor can quickly have a cursor reading and judge the quality of or the importance of your work. So it's all in the abstract and the first paragraph. And another thing that I can say, if you have an important message that you want to convey, you basically want to tell it, you want to tell it again, and you want to repeat at least 3 times, in this paper, in various places. So your reviewer and editor wouldn't miss your take-home message.
Okay. Something that I've personally wondered about is there's different writing styles for papers. Some authors like to kind of hold your hand through the whole paper and make sure that you understand everything from the fundamentals to the present. And then there's authors who just really focus on their own stuff and they assume that their audience already knows all the background necessary. How do you think, what is the best way to sort of make up for the things that people don't know when they're reading your paper, but still not spend too much time on background?
I'll probably let Yoosuf answer this first, because he's been an editor. Have probably seen more different styles people do this type of things.
Okay. Well, I guess the best way to address your question is to, as a reviewer or editor, and Huolin, you can comment on this too. But, when I review a paper, this is what I usually do, right? You got the manuscript in front of you. I read the abstract. So I get the general theme of what you did and what was the main result. Then I just look at the figures. I go straight to the figures and I look through it. And then I try to figure out if the story makes sense based on just the data. I'm not even looking at the text yet. I'm looking at the figure captions. I'm looking at the data all the way through. And as I'm doing it, I'm trying to see if I can make a prediction of the types of conclusions that I might presume that you're going to say in your summary conclusion statement, with the notion that I probably already read 1 or 2 of the main conclusions in the abstract already. But are those things actually coming out of the data, right? Can I see it? If I'm not seeing it, then it's not like, oh, it's doomsday, but it's like, what's going on? Why am I not seeing this? Do I not know what I'm looking at? Or do I not understand the data? The data should be very self-explanatory. So just the design of the figures, and hence the design of the experiment in and of itself, was it done in a cohesive, coherent way that I can readily understand how you came to that conclusion? So maybe I'm getting there, maybe I'm not. So then I look at your conclusions and I say, well, all the different things that led to the main impact statements that you said in the abstract, am I seeing it summarized here? And, I have seen times where there's a disconnection between the abstract and the summaries, and that's something's wrong there. So if I'm still having trouble, then maybe I didn't understand your data. So I go to the results section, right? So that's where you actually explain what you did and what you saw. Like that's the observation side. Or what are your observations? So you're actually explaining all the important things that you're seeing in the data. So maybe you're highlighting something in the plot or in a point, and yeah, I saw it in the figure caption. Maybe you didn't explain that this arrow is pointing at something in figure 4. Okay, well in figure 4, the white arrows are pointing towards something. Oh, okay, so I'm following the story. But if I can't necessarily make still the connection between the results and your conclusions, then the discussion section, right? So that's where you're bringing the context of what people have done out there in the literature and comparing it to what you're seeing now, right? And so now you're actually taking the results and putting it in the context of what's out there, all right? So if I'm already having to get to that point where I really need the discussion section to help me really understand what's going on, 1 of 2 things is happening. Maybe I'm just not an expert on this topic or on how you're accumulating this data, which means I shouldn't be reviewing this, right? That's on me, that I'm struggling with that. The other possibility is the story's not there. Something's wrong. I totally understand what the results are, but I am not making a connection to your conclusions. Maybe the experiment is wrong. Maybe your interpretation is wrong. So the last chance is the discussion section. And if I'm And I've seen papers that have a very short discussion section. That means it's done deal. Nope. They didn't really have the story, but they want this to be the result because that's what they were going for. They wanted this to be the conclusion. And this is the best. They can kind of sales pitch it. And then that's it. It just evaporates. And I've seen that. And so if the discussion section either humbles me or validates that, no, this is not a very well-defined study, right? So I'm not telling people, make a huge discussion section, just pour, but that's where the analysis is, right? There's results and then there's analysis. And that analysis is putting things in the context of what's gone on in the recent literature, what other people have done. That's pertinent to how these results are being interpreted to form the conclusions that you're going to highlight at the end. So at the discussion section, that's where the conclusions are being made. And then they're all put there at the end. And I'm either, wow, that's really great, or, oh no, that did not connect at all, right? So that's the process. So in terms of style, it should be clear. It should be coherent. It should be cohesive. And keep that in mind, because what I'm saying, whether it's me or someone else, most of us, we just don't have time to dive into all the text, when we're trying to review for whatever, for an award, for acceptance to a journal, or just because we're interested. When you do lit searches as a student, especially now, you're doing lit searches for your thesis or to set up or to get an idea of how you're going to design your experiment. Notice what you pay attention to, right? Is it any really different from what I actually just said? You look at the abstract, you look at the results, and then you decide pretty quickly, is this paper really useful to me or not? And then you move on, right? You got to keep going. So that's what we do in review. We're looking at the data, right? More than very, very quickly. And so if there's going to be any issues that come out, it's in your figures, right? Are they designed well? So this is when you think about style, while it sounds superficial, this is where it gets into the details of how you approach the microscope or how you approach your instrument tools. You got to think about the end result at the beginning. So you want to be able to publish, not every image that you record, but potentially when you're sitting there acquiring an image, this might be a figure, right? As it's scanning. So how many pixels? Is it 512 by 512? Should I be doing 2048 by 2048? What magnification? Should I be at 5000x for each of these images, for each one of these samples? Because I'm going to have to put these results together side by side. I'm going to want to show a feature getting bigger over time or as a function of whatever parameter. So I want to record images under the same conditions, not just magnification, the contrast and brightness settings, the spot sizes, the beam currents, the beam energies. Don't make those variables. Those are things that you control on those instruments, and don't introduce those as variables needlessly, right? That can cause variations in contrast or variations in edge effects or various things that could vary the feature size in an artificial way. But also that's going to make things easy for you later on. You collect all your images, you pick the ones that you want, you put them into the PowerPoint or Photoshop, whatever. But when you organize them, you don't have to recrop and resize so that the scale bars are the same. It kills me. It kills me to no end when people put two micrographs side by side and say, see how this thing is bigger than this one? And I have to look at it. It's like, no, there's two different scale bars. So I have to resize in my head. And that's the more work you're putting on your audience, the quicker they're either going to tune out, or they're going to question you as the researcher. If you're not paying attention to even those details, what else are you not paying attention to? You start to immediately lose credibility because of the style, just because the figures are slightly different scales. This one's really pixelated and this one's not. Did they literally take a low mag image and just took a small section and exploded it out? I mean, really? They didn't bother to take a higher mag image? They just forgot? So think about ahead of the time, what are my figures going to look like, right? And it doesn't hurt to actually sketch them out. Sketch your figures. What are the images that you think you actually want? What are the plots? What are the histograms? like you're going to record EDS spectra. Is it going to be 0 to 20 keV, or is it going to be 0 to 10 keV? That's going to be your EV per channel. That's something that you control, and that's something you need to think about before you even go to the microscope. The more you think about those things and think about what do you predict, is one element going to be higher than the other in terms of the signal? Sketch that out, and then in the process, you're actually fleshing out your hypotheses. Whether you realize it or not, yeah, you have hypotheses. But when you actually go to the microscope, you have a chance to think about visually, what are things supposed to look like, right? So that when you don't see what you expect, one of two things are happening. Either something's interesting from a scientific or experimental standpoint, oh, you didn't get what you predicted, or there's an artifact. Something's wrong. You prepared the sample incorrectly. You're using the wrong beam parameters. You're using the wrong detector, but you're thinking while you're acquiring the data, right? So if you're thinking about the figures, sorry, I need to stop. So if you think about the figures way ahead of time, that's going to go a long way towards even the design of your experiments. Sorry.
No,
I'll stop there.
No, that was all great. So in summary, your figures should tell the story on their own.
Yeah.
And that's
as much as possible.
What you're saying in your abstract.
And then the text should just be simple enough to support and add additional detail.
Yeah.
Right. It needs to be straightforward, objective statements, simple logic. It doesn't have to be flowery, beautiful. It shouldn't be. You shouldn't have lots of conjunctions, a lot of commas. Simple, short, concise statements directly to either the results or related to the literature in the discussion section that connects your results ultimately to your conclusions.
Okay,
right?
Great. We have an audience question. Aubrey, do you want to relay that question?
Sure. Before we shift to hit on spoken communication, verbal communication, before we're out of time here, we had a submitted question from an attendee. Shifting gears back to the M&M abstracts. The person asked, how important is it to input all the parameters of the used equipment? Since we only have 2 pages, sometimes there's no space to write all the parameters plus the discussion. Do either panelists have something to add for that? Maybe.
Right. So you need to think about what are the important parameters you need to write. For example, convergence angle, beam current, what type of field emitter or Schottky or thermionic. So that kind of parameter you want to basically write down. And you don't need to write everything. So acceleration voltages typically is very important. So these are things that you can just basically include in either the figure caption or in the text.
And I think at the end of the day, you have to strike a balance. You have to say enough to convey that you know what you're doing, meaning you're paying attention to the microscopy, parameters, variables. You have to mention the manufacturer, but working distance. Don't. Detectors. Yes. Are you using Everhard Thornley or a backscatter? Maybe secondary versus backscatter. Fine. You don't have to say Everhard Thornley versus a Robinson detector, unless it really matters in terms of the quantum efficiency of the detector that you're comparing to something like that.
So maybe anything that could change or leave the interpretation of the data more open-ended.
Exactly. Absolutely. That's the main point.
Okay. So I wanted to ask at least one question about verbal communication. So lots of times you will be giving a talk to an audience that has, some people are new to the field and some people are really experienced. So how do you convey complex ideas in a mixed room where you may have, and keep the people who don't have the background engaged during that process?
Okay, so I think the most important thing is really think about who your audience are. Just like you write a paper. So one of the point I wanted to add for those journals, that so-called multidisciplinary or interdisciplinary journals, typically when you get rejected, even you have some of the reviewer reject you because saying that this paper is good paper, but it would be more suitable for a specialized journal. The reason you got that comment is when you write this paper, you didn't think about who are the audience of this journal, just like who are the audience of the sitting right in front of you. For example, if you submit to these fancy journals like Nature and Science, half of the audience are biologists. So when you write a paper, you want to think about, okay, why the things I'm telling here matter to the biologists, what they can learn from my paper. They may not understand, you know, everything I'm telling, but they want to get some take-home message for them as well, right? So going back to giving a talk. So the thing is that you want to give simple examples, cartoon-ish or brain teasers that even grandma can understand, or some you know, anyone with a high school degree can understand. That would be a kind of level you want to have basically to engage your audience. Even if you have a room of scientists sitting there, by having these examples really helps, because typically 1 out of 10 people sitting in the room can really understand your full talk, and most of them wouldn't. So that's just, you know, my ways of dealing with this type of problem. Yeah, giving more.
I'm laughing because I actually saw Dr. Xin do this in one of his talks. Do this like schematic for your grandma thing. So we only have a couple minutes left. I guess I would like to ask each panelist to give some parting advice to the audience about communication skills and just how to improve your communication, both written and verbally, going forward.
Okay, so what I would say is practice, practice, practice. And don't just practice, when you practice speaking to your friends. Like, not the people necessarily in your department that are like, you know, the next seat over in the office, but people that have varying scientific or even non-scientific backgrounds. How can you elevate or pitch in 30 seconds what your research is? How can you talk to your family and friends about your research to a level, you know, over a 5-10 minute period that they could actually conceptually understand, even if they don't understand the details? That gives you a lot of practice of having to think about audience and how you can restructure your descriptions of what you do and why you think it matters to different levels. Going back to the question real quick about how to figure out what your audience is, a great way to do it is, as soon as the program book is printed for any conference that you're attending, look at it. Look at where your talk is and look at the talks preceding on both sides of it. That gives you a sense. If your talk is on, you know, perovskite oxides, a specific structure, and there's other talks in that similar vein, okay, they probably know perovskites, but what are the functionalities? What are the applications? You can get a good sense of, you know, if it's all over the place in your session, then you're going to have a really broad audience, and you're probably going to talk in a more higher level, more like you're talking to your family and friends. And if the talks are very, very similar to yours, be willing to dive into the details a little bit more. Your audience is going to want to hear it. And that's what I'll say about that.
Dr. Xin, you have anything to add?
Yeah, of course, practice is a very important thing. And the other thing is always just be mindful that communication is really about, I don't know really how to express it. It's really just very important. You need to always challenge yourself such that when you're giving a scientific talk, even kids can understand what you're talking about, right? So I know that's sometimes impossible, but that's actually what I'm doing. Is every time is, can I improve this talk such that even kids can understand it, so they know what I'm doing, and that's the kind of thing that really can push you and help you to improve in terms of communication.
So
I will add one last thing, if you don't mind, and it's regarding, it just came to my head. If you want to improve your writing, read good writing, science fiction or fiction, not the Victorian stuff, because you don't want to write that style, but modern, well-written. Conrad McCarthy, don't read him because he doesn't even make full statements. But there are certain authors that write really well and are very succinct and straight to the point. The more you read, the more likely you are to emulate that when you write.
Okay, great. So it is time to wrap up. If we had maybe, Aubrey, did you have something you wanted to say? Do we have any more attendee questions that we need to get to, or?
You cut out for me there for a second. Can you repeat yourself?
Is there another attendee question that we need to get to? Or are we?
That was the only one we had.
Okay. Okay, great. Well, thank you everyone again for coming. And thank you to our panelists. We give you a round of applause. You probably can't hear us, but thank you. And this will be posted on YouTube so people can come and revisit some of the advice that you've given today. And we'll make sure that everyone here who's attended has a link to that. So
one more reminder to drop your email addresses in the chat so you can be entered for the gift card drawing.
Thanks to you guys for organizing this. I really appreciate you guys putting in the effort, and I hope this will be useful to others.
I think we covered a lot of, I found it very personally useful, so I think it'll be good for everyone. Okay, thank you.
Thank you for organizing this. Thank you.
Yeah, thank you. Bye-bye.
Thanks, guys.
All right.